Alright friends, welcome back. In this video I'd like to go ahead and proceed with a second day for section P.5 from your textbook. So in the last couple of videos we did a couple of little mini videos for the day 1 of P.5, and we talked all about how to find domains, we talked about how to simplify rational expressions, and also how to multiply and divide them. In this video I only want to talk about one concept, and that is how to add and subtract rational expressions. Okay, so don't forget from one of those previous videos that rational expressions at the end of the day are simply nothing more than fractions. Okay, so really what we're going to kind of remind ourselves here is when we added fractions and subtracted fractions back from elementary school. Okay, and just kind of keeping in mind a couple of the little subtle nuances, just because we are working with some algebraic expressions in the numerator and denominator. Okay, and so instead of going ahead and reading through those steps there, these are things that you can go through and read on your own. I'm just going to go ahead and start off with an example. The way I really want to kind of present this today is by reminding you of what you did in elementary school and then relating that to what we're doing here in high school. Okay, so maybe as like an elementary school Part A example, what if you were to solve the following type of problem? Like, what if you had something like 5 over, let's say, 7. I'm just going to make up these numbers. And then you're going to add on, let's say, 3 over 7. Okay? Well, maybe you're watching this video, maybe you just saw me write that down and you automatically came up with the answer, or maybe you're still thinking about it a little bit. But what I'll remind you is that when you were in elementary school, when you wanted to add fractions, what you had to look out for are that the denominators were the exact same as each other. That's called a common denominator, okay? And if you had a common denominator, then that means you have the green light to go ahead and just simply combine the numerators by this operation in between them. So in this case, that's adding. So that would simply be 5 plus 3 all over 7, or in other words, that would just simply be 8 over 7, and that would be the answer to your elementary school problem. What I want us to do is I want us to kind of relate what we did in elementary school to what we're now doing in high school with these rational expressions, okay? Very, very similarly, you might notice that we have the same denominator in both of these rational expressions. Just like we had the same denominator in our elementary school example of 7, we have the same denominator up here in our rational expression. This time it's just x minus 1, the expression, the binomial. Well, since they're both the same, just like we did in elementary school, we now have the green light to go ahead and combine these numerators here with this operation in between them. So we can go ahead and write that as 5 plus x all over the common denominator, which is x minus 1, okay? So we check to see if they had a common denominator. We just combine our numerators here. The only other thing I want you to think about is making sure that whenever you write down a polynomial in any way, whether it's a polynomial on its own or if it's a polynomial showing up in one of these rational expressions, I always want you guys to go ahead and write those polynomials in standard form. Just get into that habit, right? And so standard form, of course, means that we write our x's first and then our constant after that. So x plus 5 is how we should write that numerator, and that is over x minus 1. And I'll go ahead and box that as my answer here. It's as simple as that, all right? The only other thing that we want to do here is point out any sort of domain restriction, right? So we talked about that a couple of videos ago, where we're listing all of the different values that we are not allowed to plug into this expression because it would break one of our rules of algebra. And so pretty straightforward here, what you might find is that since we have a denominator that looks like x minus 1, there is one forbidden value that we are forbidden from plugging in, and that is the value of 1 itself. If we did that, then that would be 1 minus 1 in the denominator, and that would make 0. And we can never have a 0 in the denominator because we can never divide by 0, okay? And so what I want you to kind of think about as we go through examples today is what that restriction on the domain would be. That's something I always want you to get some practice with, okay? But simple as that. So here we have this next example, part B. And as an elementary school version of this example B, what if I gave you something like 6 minus 5 over 3, something like that. Maybe something without the x in it. Okay, well, how did you handle this in elementary school? Well, one of the things that you might did is, since 6 is a whole number and you're trying to subtract off a fraction, is one of the first things you did is probably made 6 look like a fraction itself, and maybe write that as 6 over 1. And then whenever you subtracted off the 5 over 3, we notice here that our denominators are not quite the same. You've got 1 and you've got 3, and we know from the previous example that you can't really combine your fractions unless they have that common denominator. So what I might do here is I might introduce something to the numerator and denominator of one or both of my fractions so that I end up with a common denominator here. And since I just have denominators of 1 and 3, I could do that really simply by just taking the denominator of the first fraction and just simply multiplying it by 3. Then that is going to be giving me a way to go ahead and say here that I have 2 denominators of 3, and then I have the green light to go ahead and combine those numerators. But I can't just multiply the denominator by 3 without also multiplying the numerator by 3, okay? Because I want to keep things proportional in my fractions. So 6 times 3 in the numerator, that would just be 18. And then I could subtract off my 5 over 3. And then I have 2 common denominators. I got 3 and 3. So remember what we said in the last example. You now have the green light to go ahead and combine those numerators using that operation in between them. So that's 18 minus 5. That'll give you a 13. And of course, we're going to stick that over 3, and that is going to represent the solution of our elementary school version of this problem. But we are in high school, so let's go ahead and take a look at what we did in elementary school and just kind of let that be the thing that helps us figure out what we need to do here in high school, right? Well, the first thing we did is we took that 6 out front and we rewrote that as a fraction. We're going to do the exact same thing here as we take care of this example. And we are going to, of course, notice that we are dealing with 2 different denominators there. So what that's going to mean for us is that we just need to do exactly what we did in the elementary school problem, which is to introduce whatever that first denominator is missing. And so I'm going to rewrite that to leave a little bit of space, because what that first denominator is missing is a copy of the binomial x plus 3. So just like I multiplied by 3 downstairs, I'm going to multiply by x plus 3 upstairs. So I need to also do that to the top as well, right? So multiply times x plus 3, all right? So how is that going to change things? Well, we know now that because we have the same denominator, I could go ahead and write everything over that common denominator there of x plus 3. And I'm just going to encourage you to go ahead and write this out. I know that 6 is something that you can distribute in, but just to make sure that we eliminate mistakes, there are a couple of different little weird things with sign errors here in these problems. So I just encourage you to go ahead and write this out as one complete line before you might skip straight to that distribution step. So at this point, we can go ahead and distribute in, and I'm going to go ahead and continue my work here on the next line. And so my new numerator is going to be equal to 6x plus 18. And then, of course, we have that minus 5. And almost finished there. We just have some like terms that we need to combine. Specifically, we've got positive 18 minus 5. And we can combine those into 6x plus 13 all over x plus 3, okay? And so that is going to be our combined final answer here. And what we just need to now do is make sure to list whatever values would cause a problem whenever we plug them in. And of course, we look at the denominator for that. We have x plus 3, and so a value that we are not allowed to plug in here is going to be negative 3, okay? If we plug in negative 3, then that's negative 3 plus 3 in the denominator, and that's going to make 0, which we never want to have. Okay? So again, I want you to notice the similarities between what we did in elementary school and what we did in high school. This is all stuff that is very reminiscent of things that you've done in the past, and I want that to kind of be the thing that leads you into having some intuition for what we're doing here in high school. As a next example, let's take a look at part C here. Now, those denominators look almost identical. Okay, they look very, very, very similar here, but they don't look quite the same. So what we should do is we should look at what they have in common and ask ourselves what we would maybe have to introduce to get them to look the same, right? So if you look closely here, what I might do is I might go ahead and multiply the denominator of this fraction by a simple negative 1. And the reason that I might do that is because the negative here, the negative x, if I multiply that times negative 1, then that just simply becomes positive x. And if I multiply that positive 2 times negative 1, I get minus 2. And that way, you can see here that we will end up with the exact same numerator after doing that. So if I multiply the denominator times negative 1, I'm also going to have to do that same thing to the numerator, multiply it times negative 1, and then I'm going to have the exact same denominators here. Okay, so I'm going to have x minus 2, and I'm also going to have x minus 2. 5 times negative 1 is negative 5, so I'm just going to change it to negative 5 here real quick. And because I now have a common denominator in both of my rational expressions, I now have the green light to go ahead and combine these numerators using that operation in between them. So that's going to be a 3 plus a negative 5. That's going to simply give us negative 2, and that's going to be all over x minus 2. And so that'll complete the problem right there. Very, very simple and straightforward. But again, what values can we not plug in? Here, because the denominator says x minus 2, we are not allowed to plug in a 2, because that would mean we would be dividing by 0 in that problem. Okay, here in this next example, we have part D. We have two different polynomials in the denominator. So if you go back up to the guidelines, the very first step that it asks you to do in every single problem is it asks you to factor everything, okay? Factor all the polynomials that you see. So I'm not going to dwell too much on how to do the factorizations here. Again, that's something that I want you to watch a previous video for, but I will just give away the punchline here that if you factor this x squared minus 2, that's a difference of squares, so that factors into x plus 2, x minus 2. If you factor this trinomial here, that can be factored by using that method of guessing and checking. You'd have x and x, probably some combination of 1 and 2, and making them both negative, I think, will give us a negative 3x in the middle there. So again, that process goes really fast, but again, if you need to watch a past video to kind of catch yourself up with the factoring there, that's going to be something that I think is pretty important for you to do, right? So I'm going to go ahead and write my two fractions here with some factored denominators, maybe leaving a little bit of space so that we can start introducing some things here in the next step. And then we'll go ahead and continue. All right, so what I'm now doing is I'm looking at my two denominators, and they're factored now. They're broken up into factors. I'm looking at these factors, and I'm noticing that they have some that are the same. They have some that are in common. They've got this x minus 2 in common on both denominators, but you'll notice that one denominator has something that the other is missing in both cases here. So what that's going to mean is I'm just going to have to introduce what the other is missing. Okay, so for example, this denominator here has a copy of x minus 1. That's not something that this other denominator has, so that means I'm going to go ahead and introduce a copy of that to the denominator. But again, whenever I introduce to the denominator, I have to introduce to the numerator. So I'm going to go ahead and do that as well. All right. Now, this second denominator, that is missing a copy of something that the first guy has, right? This first denominator has a copy of x plus 2. And I'm going to go ahead and introduce that to the second denominator here as well, which means I'm also introducing it to the top. Okay. So now my denominators look exactly the same. They both have all three factors that we have here in the problem. They all have an x minus 1, they all have an x minus 2, and they all have an x plus 2. So what that means now is I'm going to go ahead and combine my numerators. I have the green light to combine my numerators by using this operation in between them, which is subtraction. And again, to minimize mistakes, I always encourage you to practice patience, write this out, okay? No need to hastily go through the problem, okay? We're just going to take our time here and minimize mistakes, because if you were to skip straight to the distribution, you might have missed the fact that we do have a negative sign in front of that 1 up in the numerator, and that might have led you to some wrong answers here. Okay? So now that we have this, what I want us to go ahead and do now is proceed with the distribution step, right? We have a 2 in front of that group of terms. We have a negative 1 in front of that group of terms, and we're, of course, going to go ahead and distribute those in to both terms there, right? And so if I continue here, that's going to give me 2x minus 2 after my first distribution. It's going to give me negative x minus 2 after my second distribution, and that's still all over the same group of factors in the denominator. And then the only remaining step here would be to go ahead and combine some like terms that you've got, right? So specifically here, I think we can pretty plainly see that we've got 2x minus x. That's going to give us a single copy of x in our numerator. And then we also have some constants. Negative 2 minus 2 is going to give us negative 4. So that is going to be our numerator, and of course that is all over x plus 2 times x minus 2 times x plus, or sorry, not plus, minus 1. And there's your final result right there. Okay. Now again, always thinking about what values we are allowed to plug in versus what we're not allowed to plug in. Again, all of these different factors in your denominator, these dictate what you are not allowed to plug in, because this one would tell you negative 2, this one would tell you positive 2, this one would tell you positive 1. These are the values that if you plug them in, it's going to make those factors 0 in the denominator, which makes the whole denominator equal to 0. So when we write our domain restrictions, we're going to have to say that x is not allowed to be positive 1, and it's not allowed to be positive 2 or negative 2. And I'm just going to use some shorthand there and use a plus or minus symbol for positive and negative 2. Again, you could list them out if you wanted to, but there's a complete problem right there. So in general, you are going to have to factor everything, okay? Factor as much as you can, because then that's going to give you an easier job of trying to match up your denominators and get those taken care of, okay? I'm going to go ahead and skip part E here in the video just for the sake of time, but what I do want you to notice is that if you were to go through and factor everything, x is not something that factors, x squared plus 1 is not something that factors, but x to the third plus x is something that factors. So if you factor out a GCF there, then you'll notice that the two factors that you're just left over here with are the two factors that we have in our other denominators, right? You've got your x, and then you've also got your x squared plus 1 whenever you factor that. So that means whenever you do this, you're going to have a big common denominator of x times x squared plus 1, and that's just something you would have to introduce some terms to get those to match up. So again, for the sake of time, I'm going to skip out on that because it would be the exact same procedure as all these other examples. I hope that this is something that you guys feel you are pretty confident at. If not, then feel free to let me know, and I will answer any questions you have. But thank you very much for your attention. I will speak to you guys in the next one, and best of luck on the assignment.